Based on our discussion in the last video of important decibel factors or relationships, let's look at a problem involving the use of decibels. So this could be a real-life situation. Jim likes his stereo playing loud. His stereo dial shows the volume in decibels. He turns on his stereo and has the volume at 24 decibels. His mother comes in and turns the volume down 12 decibels. Jim sneaks over and turns the volume up 3 decibels. So we want to find the volume in decibels after all the changes, by what ratio has the volume changed, and what is the final power after all of the changes. So for the first part, we're going to, let's look at what we have given. Let's put the given over here. So we have the power at the start is equal to 24 decibels. The power that it was turned down is equal to 12 decibels. And the power that was turned up is 3 decibels. So for part A, we want to find the power at the end of all the changes in decibel, and that's just going to be the power at the start. It was turned down, so we're going to subtract the power that it went down, and then we're going to add, because it's going up, the power up. So that's just equal to 24 decibels minus 12 decibels plus 3 decibels, and that gives us a total of 15 decibels. Now for part B, let's look at it in two different ways. Let's look at it for the ratio that the volume changed. Well, the first thing that I want to do is I want to take and I want to solve the formula 10 log beta equals 10 log of some power divided by, well, since we're talking about power, realistically we're talking about 1 watt. And I want to solve this for power. So I'm going to have beta divided by 10 is equal to the log of power over 1 watt. And to get rid of the log, I have to raise both sides to 10, 10th power, beta over 10 is equal to power over 1 watt. So that means that the power is equal to 1 watt times 10 to the beta over 10. So we can calculate our starting power, and we can take 24, well, we already know the formula. So let's just put in the power of the start, and that's equal to 1 watt times 10 to the 24. It starts out at 24 decibels. And remember, decibels is unitless. and divide that by 10. And we can calculate that. So we have 10 to the power of 24 divided by 10. And let's just take the approximate value. So that's going to be 251.189 watts. Sorry, I'm using my mouse. My pen decided to stop working. Okay, and then we can take and look at the power at the end, and that's just going to be 1 watt times 10 to the 15 over 10, and we can calculate that. So that's going to be 31.6228. And then our ratio is going to equal 251.189 watts over 31.6228 watts, and that's going to equal let's do here. So we're going to take the second answer back and divide that by the last answer. And that's about 7.943. Okay. And actually, I did this the wrong way. It should be the other way, because the ratio should be the end over the start. So that's going to be 31.6228 watts over 251.189 watts. Because the volume's going down, the ratio's got to be smaller. Sorry about that. So we're just going to take the reciprocal of the answer. And it's about 0.126. Okay, so that's one way of solving it. There is another way of solving it, and that's by using our half and double formulas. So we can find the ratio is going to be 2, because I either do doubles or halves, to the power of, I'm going to have the power at the end minus the power at the start, and I'm going to divide that by 3 in the exponent. So that's going to be 2. The ending decibels was 15. The beginning decibels was 24. Divide that by 3. That's 2. 15 minus 24 is minus 9. Divide that by 3. So that's going to be 2 to the negative 3. And that's equal to 1/8, or 0.125. So you notice that we were able to come up with this number fairly quickly. I didn't have to solve for the powers and then do the ratio. I could just use the decibels, the difference of the decibels, divided by 3, because that's your half power or double power ratio, 3 dBs, and then just take 2 to that value and you come up with the ratio. Now the last part is the final power after all of the changes. Well, we calculated the final power based on 15 decibels. The other way that we could do it is not having to calculate this value and just using this ratio. But the fastest way I found the ratio was with this 0.125. So I can just take and also find the power at the end is equal to, well, I can calculate this power at the start and multiply it by 0.125. So that's 251.189 watts times 0.125, and that equals 31.399 watts. So you see that it's off just a little bit, but it's off by a minor amount. You wouldn't notice the difference. And so these methods give you an approximate. When you're using double power and half power, it gives you an approximate result. But for what you're working with, it's a much easier method, and it gets you close enough to be able to have a reasonable answer.